is a great tile shape. It has got 8 equal sides, so it must be a regular octagon. And each side is 6 meters long. How can we work out its area? One way is to split up our octagon into several easier shapes, and in the center we have got our square, which measures 6 meters by 6 meters. And here we have 4 right-angled isosceles triangles. Now, we know the length of this longer side here, and by using Pythagoras, we can calculate the length of these 2 sides. And also, because we know that the area of a triangle is half the base times the vertical height, we can calculate the area of a triangle. Then there are 4 of these rectangles, each with an area that is 6 meters multiplied by the shortest side of the triangle. Another way to think of the octagon is of a big square with the 4 right-angled triangles cut off. Again, you can use Pythagoras to work out all the dimensions. A third way is to divide the octagon into 8 isosceles triangles. Now, we know the length of this side here. We can work out the angle at the center here by dividing 360 by 8, and that gives us 45 degrees for each of these angles at the center. To work out the area of the triangle, using trigonometry, we can work out the height of the triangle, and then that will tell us the area of the triangle as well. The interesting thing about this method is that it works with any regular polygon. Here's a question about percentages. This shop is offering this suitcase at 20% off its normal price of £50. So how much do I pay for the suitcase? Percent means out of 100. That's 20 hundredths off the full price. That's 20 hundredths of £50. Now, 20 hundredths is the same as 1/5. And 1/5 of £50 equals £10. Another way to do it is that we know that 10% of £50 is £5. 20% is twice that, and that's £10. So now the actual price that we pay is £50 minus our £10, and we actually pay £40. Most of the things that we buy contain value added tax. That's VAT at 17.5%. But how can we work out 17.5% of £120 without using a calculator? £17.5% seems like an awkward amount, but there's an easy way. 10% of £120 is equal to £12. 5% is half of that, which is £6. And 2.5% is half of 5% again, which is equal to £3. That's 10% plus 5% plus 2.5% equals 17.5%. So 17.5% of £120 is equal to £21. VAT is normally included in the price of things that we buy. But in business, we sometimes need to work out how much that VAT actually is. So, how much VAT is included in the price of this suitcase costing £120? Which is better value for money? This box of 80 tea bags costing £1.50, or this box of 240 tea bags costing £3.80? To work this out, we have to compare like with like. In order for us to get 240 tea bags, we'd have to buy 3 of these packets of tea, and that would cost us £4.50. In this box down here, we already have 240 tea bags, and that's costing us £3.80. So this box down here represents better value for money. If the numbers get a little bit more difficult, like 335 grams costing £1, or 430 grams costing £1.20, we have to try and find out how much 1 gram costs for each unit price. Imagine 2 different phone tariffs. Pay-as-you-go, where each call costs 35p a minute, or a rental deal where the monthly fee is £10 and each call costs 15p a minute. How can we work out which one of these tariffs will give us the best deal? One way to solve this is to plot a graph of minutes against cost for each of the phone tariffs. Now here is the pay-as-you-go tariff. We start at the origin 0 because for no minutes you pay nothing. It steadily rises up unto 100 minutes for £35. Now, with the rental deal, for no minutes, you start off by paying £10. For 100 minutes of call, charged at 15p per minute, you are paying an extra £15. That takes it up to £25 here. Where the 2 lines cross, the rental deal with the cheapest call charge represents the best deal. That's after 50 minutes of calls. I've got a bag here of assorted chocolates. 24 dark, 12 milk, and 4 white chocolates. What is the probability of me picking out 1 milk chocolate? I've got 40 chocolates altogether. Now, 12 of them are milk. So the chances of me pulling out a milk chocolate are 12 out of 40. Or, another way to put it, that's 3/10. And here it is. Now, if I put the chocolate back into the bag, what is the probability of me picking out a milk chocolate again? Here is a fraction card trick. How do I put these awkward fractions in order from smallest to largest? It's going to be difficult to look for a common denominator for all of these fractions so that we can compare the numerator and put them in order. But there is another way. Let's look at the reciprocal of these fractions and turn them upside down. 1/9 becomes 9. 2/17 becomes 17/2. 3/29 becomes 29/3. 4/33 becomes 33/4. And 5/43 becomes 43/5. So now let's turn these numbers into mixed fractions. 9 stays the same. 17/2 becomes 8.5. 29/3 becomes 9 2/3. 33/4 becomes 8 1/4, and 43/5 becomes 8 3/5. So now it's much easier to see what order these fractions go in. If we sort these numbers into decreasing order, we have got 9 2/3, 9, 8 3/5, 8 1/2, and 8 1/4. So now, if we go back to the original fractions, they will be in ascending order. 3/29, 1/9, 5/43, 2/17, and 4/33. How can I cut this cake into 12 parts with only 4 cuts? Four cuts like this would only give me 8 pieces. But one cut like this and 3 like this will give me 12 pieces.